6 cores, 8 cores, 40 cores. Okay, well maybe not the last one, but high CPU core counts are a major selling point for computers and even other electronics these days, whether you're shopping online or talking to a worker bee at your local big box store. And the idea behind it is simple. Higher core counts suggest more power, kind of like impressive looking horsepower numbers on a car. But is this always the case? Well, if you, like many Tech Quickie viewers, are a PC gamer, you've probably seen advice around the web or from friends that super high-end CPUs with many cores or hyper-threading on something like a Core i7 won't help you much, if at all, in games. But why is that? With the demand that current titles put on the hardware, why are people averse to spending more on a more powerful CPU? Well, the answer lies in a concept called parallelization, which means splitting a program's workload across multiple processing cores so a computer can work on 2 different parts of the same load at the same time. For example, let's say you want to know what 5 times 4 times 3 times 2 is. A single core CPU would first multiply 5 times 4 to get 20, then multiply that times 3 to get 60, and so on and so forth. However, a dual core CPU could assign 5 times 4 to one core and 3 times 2 to the other, solve both problems at the same time, and multiply the results together, effectively saving time. Since it doesn't matter what order you execute the instructions in, since you're just telling the CPU to multiply numbers, this math problem is easy to parallelize. Now, although this is a painfully simple example, it does illustrate how certain programs can take advantage of multiple CPU cores because they require lots of number crunching that can be easily split up. Applications for video editing, encryption, file compression, and even scientific research such as weather modeling do lots of calculations that can be parallelized easily. Also, computer GPUs are designed for parallel computing, since the same idea holds true for rendering 3D graphics in a game. So you can learn more about that in this video. But Linus, if my graphics card is designed for parallel processing, why shouldn't I also be getting a CPU with tons of cores? Well, the thing is that your GPU often doesn't handle much else other than pushing out frames to your monitor. Other important aspects of games, such as artificial intelligence, responding to inputs, and telling the GPU what to render, are still handled by the CPU. Because of the complexity involved in processing things like AI and other forms of game logic, and the fact that many of these code instructions for these types of things must be done in a specific order or in reaction to the gamer, they're much harder for programmers to parallelize and split the workload, especially as many current game engines aren't designed from the ground up to take advantage of multiple cores. That said though, your mileage may vary depending on what game you're playing. Some games, due to variations in the processes the CPU is handling, are more CPU bound than others and can benefit slightly from additional cores. And since getting games to take advantage of lots of cores is a bit of an unsolved problem in the industry, work is ongoing to try to figure out how to make higher-end games easier to parallelize, which could ultimately result in cooler, more immersive experiences. But for now, if you're just using your PC to game, getting anything above, I'd say about a 4-core, is probably overkill, and you're better off focusing your resources on, well, getting cores that perform well individually for one thing, and on other components of your system. Speaking of individual performance, do you wish your internet connection could perform better? Well, TunnelBear VPN is not the solution to that. No, a VPN does not make your internet faster, but what it does do is it makes it so that you can tunnel your internet to a different country, up to 20 different ones with TunnelBear, and use online services and websites as though you are browsing from that country. They've got easy-to-use apps for iOS, Android, PC, and Mac, as well as a Chrome extension, and it is as simple as choosing the country that you want to be browsing from. You know, like let's say there's a content block on browsers from a particular region, and you're like, I want to see that stuff. Boom! You click the button, TunnelBear encrypts your connection and makes it appear to all those services and websites as though you are browsing from a completely different place. And they take all the nonsense out of it. There's no port forwarding or DNS configuration or anything like that, and they've got a top-rated privacy policy too. The best part though is you can try TunnelBear VPN with 500 megabytes of free data per month, no credit card required, for free at the link in the video description. And if you decide to upgrade to an unlimited data account, you can actually save 10% at tunnelbear.com/Linus. So thanks for watching, guys. If you liked it, liked it. If you disliked it, dislike it. If you want to check out our other channels, boom, boom, cool video on Channel Super Fun right here. Leave a comment if you have suggestions for future Fast as Possibles. John really does read them, even though I'm not sure if he replies to many of them. And as always, don't forget to subscribe and follow and all of that good stuff.
How many hours does it take to complete a project? That depends on how many workers you put on the task. The same goes for computing. If you want to finish a processing task sooner, put more CPUs on the job to share the workload. The trouble is, most computers only have one CPU socket in the motherboard, so until recently it hasn't been possible to set multiple CPUs onto a single task. But all that has changed with the introduction of multi-core CPUs. A single-core CPU consists of a key set of components that work together. The arithmetic logic unit, or ALU, does the math calculations. The control unit directs the activities of the CPU. The registers provide temporary storage for data being processed. A multi-core CPU has more than one set of these key components. Each core has its own separate ALU, control unit, and registers. When data arrives for processing, the CPUs share in the work, with the processing tasks distributed so that each core is kept as busy as possible. The processed data exits the CPU chip as if it were exiting from a single CPU. In actual usage, multiple cores don't exactly multiply the number of instructions per second that the CPU processes. That's because there are many other factors involved in throughput that having multiple cores doesn't improve. For example, a CPU may wait for data to be retrieved from memory. Such a wait is called latency. Even so, a multi-core CPU has a significantly higher data throughput rate than does a single-core CPU that otherwise has the same specifications.
In this video, we're talking about CPU cores. What are they? How do they work? And how many do you need for video editing, graphic design, photography, or whatever creative profession that you are in? If you're new to the channel, I'm Benji Kaiser, and you're watching Don't Tech With Me, the place where you find the latest tech news as well as tech terms explained. So if that sounds like your kind of place, consider subscribing and ring the bell so you don't miss out on any of the future videos. Currently, what you are watching is the series that I'm doing on tech terms, and specifically, we're talking about CPU cores. What is a CPU core? Well, of course, it is the amount of cores on a CPU. When the CPU was first developed, it had one CPU core on it. Every task that the computer ran was handled on that singular CPU core. But as technology developed, computer manufacturers brought us multiple CPU cores. Now, I will interject quickly if you're curious about other tech terms to be explained, specifically for video editors and designers. You can head on over to the channel and check out the different playlists where I explain each different component in the computer in depth. So, core counts identified. How many cores are now available on CPUs? Well, to explain what you see as far as terminology is concerned, 2 cores is a dual core, 4 cores is a quad core, 6 cores is a hexacore, and 8 cores is an octa-core. Now we move up to 12 cores, 16 cores now, and actually the largest core count on a processor should be coming out this year from Ryzen. So this was announced at CES 2020. They have a 64 core processor, CPU, coming out in 2020. This processor is probably going to be around $3,000 to $3,500 or beyond dollars. So it's pretty insane how expensive this processor is, but it is a beast of a processor. Okay, so how do cores work? How does it work? To simplify things, each core is seen by the computer as its own processing unit. At first, manufacturers tried to install multiple CPUs on one motherboard. So they try to take separate CPUs, build a larger motherboard with more CPU slots, and build it out with more CPUs. But that served to be expensive. Plus, there was the issue of latency. If you're curious about what latency is, I want to make a whole nother video on that. So keep an eye on the channel or the YouTube cards above. The CPU is able to split up the work onto an individual core. So, Core 1, Photoshop. Core 2, Premiere Pro. Core 3, Google Chrome. Core 4, Spotify. So rather than doing multiple CPUs on a motherboard, they were able to internally alter the CPU to have extra cores. This allows you to divide the work, and each core handles a specific program. But the question comes, what if I have more programs open? So say, for instance, you then open another app inside of Adobe, so like InDesign or Illustrator. What if you have more programs open than cores available? Will your computer explode? Well, no, it will not explode. When you load a program, say Photoshop, a process is created, okay? So that process is assigned its own memory, so RAM. If you want to watch more about that, I have another video on the channel about RAM, and credentials. So that's kind of like a serial number. So it has an identifier number and it has a certain amount of RAM attributed to that process. The system will assign that process to a specific core. If there are no cores available, it will virtually split the core into one of the core's threads. Now, threads are something that was developed after cores as a way to virtually divide out a core to create more cores. So you'll see this in advertising on computers as, 4 cores, 8 threads, 8 cores, 12 threads, 8 cores, 16 threads. So that's what we're talking about here. I will talk more about threads in another video, and again, you can check that out once it is released on the channel. If there are no cores or threads available, then the process waits its turn in line in the queue until it is called to action. So the really cool thing is about the CPU is it has an organization system. So if it can't attribute to a core, it will go to a thread. If it can't attribute to a thread, it will wait in the process, and however long it takes to get through the process, and then it will activate. If it is an unessential task to that moment, it will actually sometimes cancel out that process, and it'll move on to more important things. So it's really neat how intelligent they have made the cores and threads and the processes inside of the CPU. So more cores equals a faster computer, right? Well, not necessarily. There are a few reasons why core count alone is not enough to make for a faster processor. Here are a few things to consider when choosing a processor. The clock speed, which is rated in megahertz. The amount of threads, like we said, 8 core, 12 thread, 8 core, 16 thread, so on and so forth. The instructions per cycle, this is very important, and you cannot regularly find this information. This is not something that computer companies advertise that, our processor can do X IPC. But that's something we're going to talk about in a future video and why that is important and why a 4-core processor could be faster than, say, a 6-core processor because of the IPC rating. And then, of course, the watts. So how many watts the processor can reach. Is the processor made for, say, battery life, or is the processor made for high performance? Is it made for video editing or gaming? What is that specific processor, and how is it built, and what is it built for? Okay, so the last thing to consider is how many cores and threads do you need for video editing and graphic design? Well, like I said, this will differ according to the IPC, the instructions per cycle, but there's really no way to understand that specific classification because manufacturers don't offer that information to us. However, I will note that I use a 4-core 8-thread processor on my current laptop. I edit 1080p video. I do graphic design work on it. So I'm using Premiere Pro, I'm using Affinity Photo, I'm using Adobe InDesign. So those are the programs I'm using, and it runs it well. It's not the best performance. I do occasionally get some slowdown with the 4 cores, 8 threads, but it is a good processor. It's the i7-7700HQ. I do plan on building my own desktop computer, my own PC build, and I'm going to have at least 6 cores and 8 threads on that build because I want to be able to start doing 4K video editing and have it very smooth in the timeline, have quick exports, and be able to run multiple programs at the same time. Now, we're going to talk more about clock speed, latency. We're going to talk about instructions per cycle. We're going to talk about threads in future videos. For now, this is a quick walkthrough on cores. I hope this has been helpful to you. My name is Benji Kaiser. You're watching Don't Tech with me, and I'll see you here on the next episode.
Hey guys, today we now study about multi-core processor. Before studying that, I would like to focus you on some small topics like what do you mean by core? Core means a basic simple computation unit of CPU. For example, it means something our brain does. It processes one program instruction at a time. Now guys, we focus on what do you mean by processor. A processor works like which gives the input and provides the appropriate output like what our nerve cells does. So now you could easily understand what do you mean by multi-core processor. A multi-core processor is comprises of more than two core which reads and executes the instruction. Now we show you how a picture of how a multi-core processor looks. So now guys we will understand what multi-core processor do. For example, if you want to listen to music, work on Excel sheet, browse on internet, so you can understand it can handle multiple programs at once. And secondly, for example, you open a Google page and each time a different process has been done in new tab. So it can use multi-core processors at a single period of point of time.
Before we learn about working of multi-core processors, let's learn a few basics. A thread is the smallest sequence of code that can be executed by an operating system. Multi-threading is the ability for an operating system to take advantage of multiple cores by splitting up the code into threads and feeding it to different cores simultaneously. Hyperthreading is a technology used by Intel processors in which the OS treats a single core like two virtual cores. This speeds up the process as the processor is never free. In a multi-core processor, the operating system can tell the processor to do multiple things at the same time using separate cores. Essentially, through a direction of the operating system, data is moved from the hard drive via the motherboard to the processor. Multiprocessing is implemented through data sharing. With multi-core processors, there are multiple levels of cache called L1 and L2 cache. Some processors have cache up to L4. These levels of cache memory ensure that the processor don't have to look very far to find their next process, saving a lot of time. L2 cache is larger in memory but slower than L1 cache. Usually in a multi-core processor, L1 cache is unique to each processor and L2 is shared. One of the main advantages to having a shared cache is the ability to use a cache to its fullest because of the fact that if one core isn't using it, the other can. In a multi-core processor, when searching for data, a core can look through its own unique L1 cache and then branch out to shared L2 cache, then RAM and eventually the hard drive.
Parallel processing In computers, parallel processing is a processing of program instructions by dividing them among multiple processors with the objective of running a program in less time. The next step in parallel processing was the introduction of multiprocessing. In these systems, two or more processors shared the work to be done. The earliest versions had a master-slave configuration. One processor, the master, was programmed to be responsible for all of the work in the system. The other, the slave, performed only those tasks it was assigned by the master. Traditionally, computer software has been written for serial computation. To solve a problem, an algorithm is constructed and implemented as a serial stream of instructions. These instructions are executed on a central processing unit on one computer. Only one instruction may execute at a time. After that instruction is finished, the next one is executed. Parallel computing, on the other hand, uses multiple processing elements simultaneously to solve a problem. This is accomplished by breaking the problem into independent parts so that each processing element can execute its part of the algorithm simultaneously with the others. The processing elements can be diverse and include resources such as a single computer with multiple processors, several networked computers, specialized hardware, or any combination of the above.
Now I talk something about Intel processors. Intel Core is a line of mid to high end customer workstation and enthusiastic central processing unit marketed by Intel Corporation. Now, some of the Intel Core processors are first coming to i3. The first Core i3 processor was launched on January 7, 2010 with two core processing units and hyper-threading. Some of the four common features are low power consumption, small cache. Now, coming to Wi-Fi. The first Core Wi-Fi was introduced on September 8, 2009. A mobile Wi-Fi processor has two cores and hyper-threading. The desktop ones have four cores with no hyper-threading, but they all have in common is improved onboard graphics and turbo boost. Now, coming on to i7. Intel Core i7 has an Intel brand name applies to several families of desktop and laptop 64-bit versions. The Core i7 brand targets the business and high-end customer markets for both desktop and laptop computers. All Core i7 has hyper-threading for heavy workloads. A Core i7 can have anywhere from 2 processing cores in an ultrabook to 8 processing cores in a workstation. It can have 2 to 8 memory sticks. Core i7 have a lot of varieties, but there are few common features like more cache and better onboard graphics and fast turbo boost that are low tide processors. Thank you.
Now let me note down some problems with single core processors. Most of the programs which are made today need dual core processors to run. To execute the work faster, you need to increase the clock time. Increasing the clock time drastically increases power consumption and heat dissipation to extremely high levels, making the processor inefficient. Now, here are some advantages of multi-core processor. Energy efficiency. By using multi-core processors, architects can decrease the number of embedded computers. They overcome increased heat generation due to Moore's law, that is, smaller circuits increase electrical resistance, which creates more heat, which in turn decreases the need for cooling. The use of multi-core processing reduces power consumption, which increases battery life. Now, performance. Multi-core processors can increase performance by running multiple applications concurrently. The decreased distance between cores on an integrated chip enables shorter resource access latency and higher cache speeds when compared to using separate processors or computers. However, the size of the performance increase depends on the number of cores, the level of real concurrency in the actual software, and the use of shared resources. Now, let me note down some disadvantages of a multi-core processor. First and the biggest disadvantage of a multi-core processor is the cost. Cost of a multi-core processor is very high as compared to a single or a lesser core processor. For example, the cost of an Intel i3 processor is around 9,000 rupees, which is a dual core processor, whereas the cost of an i7 processor is around 35,000 rupees, which is an octa-core processor. Now, it is a common myth that multi-core processors have twice the efficiency than that of a single core processor. but it is not true in practical. Another disadvantage is a multi-core processor is very hard to manage thermally when compared to lower density single core processors.
Based on the current models, the future of multi-core processors may include increasing the number of transistors per square millimeter inch of silicon, efficiently increasing the number of cores, increase the cache in the processor, better materials for transistors, more environment-friendly processors, improved battery life, better software with improved threads.
At some point, everyone learns that a CPU has a variable number of cores inside, and that number influences your processor's performance. Usually right after, people then want to know how many cores their CPU has. The good news is, figuring that out is extremely easy in Windows. In both Windows 10 and 11, just tap the Windows key on your keyboard or click on the Start menu button, then begin typing the word System. The top match should be System or System Information. Either will work, so hit the Enter key or click on that result, and a window will appear that lists your hardware information, including the name of your processor and the number of cores that it has. Alternatively, you can press Control-Shift-Escape on your keyboard to bring up the Task Manager window. In the upper right of the Performance tab, you'll see the name of your processor and the number of cores that it has. You'll also see a graph showing your CPU's utilization in real time. Underneath the graph are more detailed stats like the base clock speed, cores, and logical processors, also more commonly known as threads. That's all you have to do to find out your core count. However, the story doesn't actually stop there if you're trying to figure out how powerful your CPU is. Core count is just one clue about CPU performance. Processor frequency, also known as clock speed, multi-threading, the generation of the chip, the type of CPU, whether that's desktop or mobile, and software optimization also play a role. You can look up the raw specs of your processor online really easily, like on Intel's ARC website or AMD's processor specification website, but honestly, the easier way to tell how well your CPU stacks up is to simply look up benchmark results for the things you do regularly, whether that's office work, gaming, video encoding, etc., etc. Generally, the newer the processor, the more efficient and more powerful it is, but not all generations make huge leaps in performance over previous ones. Looking up actual test results tells you concretely the gap between generations. The same applies to competing CPUs from the same time period. You might expect a top-tier part with fewer cores to underperform a rival maker's best chip, but that's not necessarily the case. Sometimes they end up being in the same ballpark, making the choice more about cost, availability, and the specific programs and games you'll be spending time in. Same goes for thread count, or a CPU's capacity to handle multiple processes at the same time. CPUs with higher thread counts are just better multitaskers, and that only matters when you regularly do multi-threaded work. And even when that's the case, still be aware that the generation of your chip still plays a bigger role in its performance. The short of it is, core count isn't everything, nor thread count, nor even the age of those cores and threads. It's more nuanced than that. More importantly, if you have no complaints about your PC when you're using it, then you don't need to upgrade or make any changes at all. So that's it for this video. Thanks for watching. If you want to know more about CPU performance and how specific processors stack up, be sure to subscribe to our channel. Also, if this video is helpful to you, give it a like. Otherwise, I'll catch you in the next one.